Okay, this is Unit P, Day 5. And we're going to work on solving equations graphically, numerically, and algebraically. So first off, I'll just fill out this whole column over here. This first guy here, it's 2x minus 1 equals 10. Remember from Algebra 1, the number of solutions. So the possible number of real solutions, or just the total number of solutions, is going to be the highest power you see on the variable if it's a polynomial like this. So the highest variable I see is a 1. So there's going to be one solution to this. And the type of equation is that's linear. Okay. This guy, the highest power is a 2, so there's going to be two solutions. Now they may be real, they may be not real. You could have some imaginary in there, but there's going to be two solutions of some kind, and we call that a quadratic. This guy here, if you remember, this doesn't really follow that pattern because it has an absolute value in it. If you remember absolute values, they make a V shape. Okay, so we got a V shape, and we're trying to see when does a V shape equal a straight line. So we're going to put on the possible number of solutions here. So you think a V shape, and if I do a straight line, I could possibly have no solutions. I could have one solution, or I could have two solutions. So we're going to go by the highest number of possible things. So two solutions, one solution, no solution. And the type of equation this is, it's an absolute value. Absolute, save some space. And then the last one down here, it has a third power. So that means it's going to have up to 3 solutions, and we call that a cubic. The highest power is cubed, so it makes a cubic. Okay, now solving these guys. It's going to gradually get more and more difficult as we go here, but not too bad. So solving it, there's really only one way to solve this algebraically. So save some time. So you solve it and you get 11/2 or 5.5. Now graphically, and this might seem kind of silly, there's two ways of doing this. First off, I think the simplest way is, so we go 2x minus 1 equals 10. Well, if we set it equal to 0, so 2x, if I subtract 10, would be minus 11 equals 0, and then graph that. Graph 2x minus 11. So what I'm going to do here, I have that. I'm going to turn these off. Okay, so just only this one's on right now. So 2x minus 11, I'm going to hit graph. There it is. And what I'm looking for, up here it says equals 0, so I'm trying to find what x makes it 0, makes the y 0. So y is 0 right there. Okay? And you could zoom in, you could do a lot of other, there's all kinds of, we can make a table and do that. I think the fastest way is to do this intersect idea. We're going to let the calculator find it. So I'm going to push second and then calc. See, it says calc above my finger, second calc. And I'm sorry, I don't know what I said earlier. I'm going to do 0. There's an intersect, we'll do in the other one. But I'm going to look for the 0 because 0 is where across the x-axis. So 0. It asks some questions. It says, what's the left bound? I need to pick a number less than that. So I'd say 3 or 4 is definitely less. I'm just going to put 3. How about a right bound? Well, it's over here somewhere. So if that's 3, 4, 5, 6, 7, 8, something like that. And then I guess I'm just going to scroll over and put somewhere in here. And it tells me that when y is 0, x is 5.5. That's what I got over here algebraically. So that's one way of doing it. So one way is to set it equal to 0, graph it, and look for zeros. So I'll just say zeros. Okay. The other way would be to graph these two as individuals. So graph y equals 2x minus 1 and graph y equals 10. Okay. So I go y equals, I'm going to turn these on and turn that off. And I'm just hitting enter to shut them off. I want to keep that, but I don't want to graph it right now. So when I hit graph on this guy, I'm going to have 2 lines. And I want to look at where do they cross each other. So what x value makes them equal? What x value makes these two the same? So I'm going to go second. So I'll bring this up here. So second, calc again, but instead of 0, I'm going to choose intersect. Which curve? Doesn't matter. You can do the red or the blue. So hit enter. And then how about the second curve? Just make sure the other curve is entered. And then as a guess, try to get somewhere close to it. It doesn't have to be perfect. If it intersects twice, you got to be closer to the one you're looking for. But here, there's only one intersection anyway. And notice, right there, x is 5.5. So both ways you do it, you get 5.5 for an answer. Okay. Now, number 2. This guy, algebraically, But we did a whole unit on this in algebra 2. So you got 2x squared minus 7x. You want to bring that over. So minus 15 equals 0. We want to do two binomials. So you want to do two numbers that multiply to give you 2x squared. So it'd be 2x and x. And then I got to do two numbers multiply to give me negative 5. But then when I do my outer product and my inner product, I get negative 7. So you can kind of guess around with that. I'm just going to save some time. This is plus 3 and that's minus 5. So you see 3 times negative 5 is negative 15. Outer product to be negative 10. Inner product is 3. That makes negative 7. So that's how I know it's right. And then if these multiply to equal 0, that means I'm going to have negative 3 divided by 2. So negative 3 halves. And then the other one would be 5. So negative 3 halves and 5. Now how would I solve that graphing? Same idea. I could do 2x squared minus 7x minus 15 equals 0. And I could look for zeros. Or I could graph y equals 2x squared minus 7x, and I could do y equals 15 and do intersect. I think this way is faster because you're only typing one equation in. Here you got to type in two equations, wait for it to graph two different equations, and then do your intersect. Okay, so that one, I'm going to let you do on the calculator if you want to practice with that. This guy, again, we said that, we're for the graphing. So let's say we want to solve this. So we got 3x plus 2 absolute value, and that equals x plus 12. So if you remember from absolute value stuff, it's the value of whatever's inside of this. It equals that, or it equals negative that, because if it was negative that, the absolute value would drop. Okay, so kind of like if I do this, if I said the absolute value of x equals 3, x could have been one of two things. It was either 3 or it was negative 3, so I'd make positive negative. So here I got 3x plus 2, that actually equals x plus 12, or 3x plus 2 equals the opposite of that, the negative of that, so that would equal negative x minus 12. Okay, there's two options for that. I'm going to solve this quickly. So in the end, x equals 5 or it equals negative 7 halves. Okay? If you want to make sure, you can plug them both in and it'll work. Now the graphing part, same thing. We could do y equals the absolute value of 3x plus 2, and then bring these guys the other side, so it'll be minus x minus 12, and then look for zeros. Or you could do y equals the absolute value of 3x plus 2 and y equals x plus 12 and do intersect. Okay, I will say real quick here, if you have trouble, we want to put in absolute value in here. If you're trying to graph absolute value, let's say I want to do this first guy here. I want to graph this and look for zeros. To get absolute value, you push math over the number, and then it's the first option. Hit enter. Okay, so we got 3x plus 2 minus x minus 12. Graph it. It should make a V shape. This one does have two solutions. There's a V shape that actually hit the x-axis twice. If I look in there, this one's negative 3.5, and this one's at 5. So I got it. Now the other way, I'll have a V shape and a flat line. It'll hit at 5 and negative 7 halves. Okay. This third guy here is a cubic. So this one, we're going to use a process that I'm not sure if you guys remember it. It's not used very often. We're going to factor by grouping these guys. So grouping is a method that works with cubics sometimes, and honestly overall hardly ever works, but a lot of times we give you problems that you can factor this way. So we're going to group these guys. We're going to split it in half. Okay, so look at the first two here. What could I factor out of those two? I could take an x squared out of both of those. Over here, what can I take out of both of those? I can take a positive 9 now. Okay, now I got two things being added together. Two products, this product and that product. What do they both have? Well, they both have an x plus 2, so I'm going to factor that out of both of these. So I'm going to take an x plus 2 out front. What's left is x squared and plus 9. Okay? Now when I go to solve those guys, I'm going to set this equal to 0, I'm going to set that equal to 0. Now that first one, not too difficult, that's a negative 2. This guy, if I take x squared plus 9 equal to 0, bring the 9 over. Okay, that's one of those, because I square rooted, I got a plus and a minus. The square root of negative 9 is going to be 3i. If you remember, if there's a negative in the radical, you got i's in there. So I got 1, 2, 3 solutions. Only one of them actually exists, but I told you, there's possibly 3. Well, there's our 3. Okay. And now this guy, there's only one, since it's set equal to 0, we don't, this intersect really isn't an option because you'd be graphing y equals 0, which is the x-axis. So you want to graph that, so y equals x cubed plus 2x squared plus 9x plus 18, and look for zeros. Okay, on the back side here, I'm running, I got about 4 minutes left, so I'm going to speed through some. I'm going to do a lot of pausing the video. Here's 4 examples, and this is all about methods for solving quadratic equations. So quadratic equations are ones that have squareds in them. So x squared somewhere in there. 2 is the highest power. So the first one is factoring, like we talked about on the front side. So I got 2x and x. I want to kind of fiddle around and see what multiplies me negative 2, what adds outer or inner will give me negative 3. And in this case, it'd be plus 1 and minus 2. So that means x would be negative 1/2 and 2. Quadratic formula here. Quadratic formula, you got to make sure it's set equal to 0. So I got 3x squared minus 6x minus 5 equals 0. Identify your a, your b, and your c. And you're going to plug that into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Maybe you have a fancy song for remembering that, or a rhyme that helps you remember it. And then you plug in a, b, and c. Okay, so you plug them in, and then you simplify. And I would just use a calculator for this. Type it in the calculator, and if you're really good at parentheses, you can do it all at once. You can do the plus all at once, and then do the minus all at once. Plus and the minus. But in this case, I get 2.633 and negative 0.633. Take a turn with the calculator and practice that. The next one is completing the square. Completing the square was probably the one that you avoided the most. The big thing with completing the square is you want this to be a 1, x squared. So I'm going to divide everything by 4. And I want to check, is this number half of that number squared? So half of 5 would be 5/2, squared would be 25/4. That's not this number, so I want to bring that to the other side. And then I want to put in the number I want. The number I want is half of this number squared, so negative 5/2 squared. And I know that this is going to be an addition because anything squared is plus. So negative is positive, so it'll be plus, which means I have to add that to this side also. Because I chose that number, ends up being 25/4, that's the perfect number that makes this a perfect square trinomial. And that means that it's a binomial squared. The binomial squared is going to be, just the trick is half of that number. So it'll be minus 5/2. Now on the other side, and this would be 25/4. So that's going to be 8/4 or 2. And then I want to solve. So square root both sides. So yeah, these are all just ways of doing quadratic equations. So anything that has an x squared in it, one of these will work. In fact, most of them, like this one won't work always. This will always work. This will always work. This one is, if it gets to that, it will always work. So these two work all the time. It's just they're not always as fast. This is a pretty fast way if it works.